and welcome everyone. In this chapter, we are going to discuss about the STP introduction, that how it works and what exactly is. Since we have discussed the basic point that why STP is needed, and that was all about just to avoid the switching loops. So now let's move ahead and see how exactly STP works. So this was the scenario which we have already seen, and let's see how exactly STP is going to run in this topology itself. So first of all, you need to understand, as we discussed, there was a loop happening in this particular topology, and just to avoid that loop, we have got the STP protocol here, correct? So say this. So STP is one of the open standard protocol which is supported in all of the switches, whether it is Cisco or Juniper or Barracuda, any switches, STP will be there. And STP stops the loop when we have the multiple links between the switches. And make sure STP uses the spanning tree algorithm itself. STP spanning tree algorithm. And STP is enabled by default into the Cisco switches whenever you connect the redundant link. Now, how exactly STP works? The process of STP. See, so STP has something called as the STP election process. And based on STP election process only, you need to understand this algorithm. Okay, so let's get started how exactly STP works and everything. Say this. So first of all, there is STP election will take place. STP election. Okay, STP election. Now make sure this STP election, the very first start with the root bridge election, root bridge election, or you call it as root switch election. Okay, so this root bridge election happens based on some criteria. The criteria will be like, first it will be like lowest bridge ID, lowest bridge ID. Okay, and this lowest bridge ID is basically considered with the combination of two things. The first, it will be checking lowest bridge ID, that is nothing but lowest priority, and second thing, it will check lowest MAC address, lowest MAC address. So make sure what is this lowest bridge ID. Lowest bridge ID is all about priority plus MAC address is equal to bridge ID. Priority plus MAC address is equal to bridge ID, and by default the priority in Cisco switches you will find as this. By default priority will be 32768. By default priority 32768. For all the switches it will be same, 32768. Make sure the default priority will be 32768, and the lowest priority will be considered as the bridge ID. But right now let's say bridge ID for priority is same. If it is same, then it will look for lowest MAC address. See that we have 00A, 00B and 00C, correct? So which is lowest one in this? You need to compare character by character. 0 0 0 same, 0 0 0 same, 0 0 0 same. Means you cannot decide till this third character. When it comes to this A, B and C, which is lowest one? So in this, of course, you can say that this is basically my lowest one, and this is basically going to consider as my root bridge. So you call it as root bridge or you call it as root switch as well. Fine. So make sure root bridge elections will take place. Initially, all the devices will say that I am the root, I am the root, I am the root. So this election will take place, make sure, in all switches. And how they will come to know each other? Basically, they are going to exchange something called as BPDU. They will be exchanging BPDU. BPDU stands for Bridge Protocol Data Unit. This is just similar to hello packet, just similar to hello packet. They will exchange the informations between the switches and they will determine the complete topology. Fine. So BPDU will be exchanged between the switches to determine the topology, and initially every switches will say I am the root by advertising their BPDUs, and the election process will take place on this. So root bridge is selected here. Apart from root bridge, rest of all like switch 2 and switch 3, these two will be considered as your non-root bridge. This is basically considered as your non-root bridge. Fine. Now the second elections will take place, which is basically called as the root port election. Root port election. And this root port election will happen where? It happens in non-root switches. In non-root switches, this root port election will take place, and there is some criteria to choose this as well. So the first will be lowest cost. Second thing is lowest MAC, which is coming in the path, and third criteria will be lowest port numbers. Lowest port number. This will be criteria. So when it comes to STP cost, make sure cost is basically defined by the IEEE, and this cost is basically defined for, let's say if you have 100 Mbps, so the cost will be 19. If you have, let's say, fast Ethernet, sorry, this cost I need to, I think, check it out. Just give me a moment. I'll show you the cost for you. So the cost is here. See this, here is the cost, IEEE revised cost, in which you can see if you have 10 Mbps of speed, the cost will be 100 for the link. If you have 100 Mbps of link, the cost will be 19. If 1000 Mbps, cost will be 4. Like this, the cost is there. Okay, let's move ahead. Say this. So say here, so this is what the cost. Let's say if you have the 100 Mbps of link, the cost will be 19. So the cost is 19 for every, let's say, all our fast Ethernet. Cost is 19. Fine. Now see, in non-root switches, root port election will take place, and only one root port will be there in one non-root switch. Okay, so root port is basically the shortest path to reach the root bridge, or you can say the best path to reach the root switch. So from this particular switch to, you can go to root switch via two path. You can go directly or you can go via this. So if you are going directly, cost is 19. If you go via this, 19 plus 19, 38. Correct? So which is best one in this shortest path? Of course, yes, this is going to be your root port because this is shortest. Done. Second, in this switch again root port election will take place. Shortest path to reach the root switch. Just 19 via this, 19 plus 19, 38. This is more. So this is again going to be your root port. Now make sure you need to go for one more point, that opposite to root port, always it will be considered as designated port. Opposite to root port, designated port. Always remember. Also, one more thing, a root switch always has the designated port. Root switch always has the designated port. No root port on the root switches. So make sure in root switches blindly you can write down the designated port only. Now which link is left over here? Between switch 2 and switch 3, this link is left over. Means the block is going to be in this only. How you can decide? So the next election will take place now. The third election. Third election is again all about the designated port election. Designated port election. Again, this also happen in non-root switch only. Non-root switch only. And what is the criteria to go for? It's the same that you have for this. The first criteria will be lowest cost. Second criteria will be lowest MAC address, and third criteria will be lowest port numbers, or you call it as lowest port ID. That's it. So to go for this, now stand in the middle here, and add the cost to reach the root switch. Okay, 19 plus 19, 38, 19 plus 19, 38. Is it same or not? See, to go for this, you need to stand in the middle here and then add the cost. 19 plus 19, 38, 19 plus 19, 38. Via both the switches, you have the same cost, no different here. Means you cannot decide this is getting tie. If it is getting tie, then what you will do? Go for second, and second one is this. See, if I am going via this, the MAC address will be 00B. If I am going via this, the MAC address will be 00C. Which is lowest one in this? 00B is the lowest one. Means this is basically going to be my designated port. Opposite to designated port is going to be your block port. Opposite to designated port will be block port. And how the communications will happen now? If it is block, in the sense the communications will take place via always root switch. Like this, the communications will happen. Like this, the communications will happen. Okay. And see here now, if this trying to communicate with this now, it cannot come via this, never, because it is block. So always the communications will happen via this. So this is how your STP election process take place. Okay. So there is three major points to remember. Your root bridge election, non-root bridge has the root port and designated port election. Okay. So one more thing which I would like to highlight, there is something called as bridge ID. Okay. You will find sometimes, see, bridge ID, as I said, bridge ID is equals to priority plus MAC address, correct? Sometime you will find the extended bridge ID, extended bridge ID or extended system ID, and this extended bridge ID is nothing but priority plus MAC address will be there. Along with that, VLAN number. VLAN number will get added. VLAN number will get added. That is called as extended bridge ID. Okay. So make sure this is some of the common and important points to remember. Okay. So that's it, how your exactly election process happened. This is all the information, and this is very, very important points to remember about the STP election process. Okay. Let's move ahead and see that couple of more things into the slide deck as well. So let's get into the same. Say this. So as we discussed this basics of STP, now the STP election process, in which you have the root switch. As we discussed, the switch with lowest, or you can say the best switch ID, will become the root switch, and out of all the switches in the network, only one switch will be selected as a root switch, and root switch will become the focal point of your network. That's very important. And switch ID or bridge ID is all about, read this, each switches has the unique identifier called as bridge ID or switch ID. Bridge ID is equal to priority plus MAC address. Default priority is this. And in case of extended bridge ID is all about the VLAN numbers will get added along with your priority and MAC addresses. Now apart from root, all other switches will be considered as non-root switch, correct? No, say this, all switches other than root switch will be considered as non-root switch. Fine. So in non-root switches, the other elections will take place, which is your root port and designated port. So we'll see that. Bridge ID, just an example. Bridge ID without extended system ID is all about priority plus MAC address. If I go for bridge ID with extended system ID, priority, MAC address along with system ID, that's nothing but this is your VLAN numbers will get added, like VLAN 1 or maybe VLAN 10, maybe VLAN 20, depends. That's it, move ahead. So the other elections which happens, the root port election, say this, every non-root switches must have a root port, and all root port will be into the forwarding state, and make sure only one root port will be there per non-root switches, and root port is the closest path to root switch, or you can say shortest path to root switch. Other election process which happens is about designated port and non-designated port elections which happens here. So say this. Designated port, as we discussed already, make sure for every root port there will be a designated port. Means wherever you have root port, opposite to that designated port will be there. And a designated port also will be in forwarding state, and all the ports you can say into the root bridge will be the designated port only. In root switch, make sure in root switches always all the ports will be in designated mode, always in designated mode. Apart from that, non-designated is all about the port that are neither root neither designated. These are basically blocked by STP, your block port. Fine. So this is what your STP election process that you need to remember. I would like to highlight this is very important points. If you remember this, steps like root port election, root bridge, then root port, and then designated port, and remember the criteria, it will help you to go for any kind of selections. And this is very good example. Okay, moving ahead. So cost, which we have already seen, like for 10 Mbps 100, for 100 Mbps it is 19, which we have considered. Like that, depends upon the speed, the cost will be there. So far, as we discussed BPDU in detail, like BPDU, as we discussed, like BPDU is basically your bridge protocol data unit. It is basically similar to hello packet, and this bridge protocol data unit is used to send the informations between the switches. It contains the informations that helps switches to determine the topology, and initially every switch will advertise that, hey, I am the root switch, I am the root switch in the BPDU. So they said there cannot be multiple root switch, let's go for the election. That's where it will happen. Apart from that, once the election is successfully done, like root bridge, root port, block port, everything is done. After that, only root switch will send the BPDU in every 2 seconds. After that, root switch will send the BPDU in every 2 seconds. So that's very important points. For example, in this, if you see, this is my root switch. So this root switch will send the BPDU in every 2 seconds, continuously in every 2 seconds. And if the root switch is going down, of course, one of the switch will become the root switch in this. Election process will take place again, and one of the root switch will be from this only. So that's it for this particular lecture, folks. I will see you in the next lecture with the advanced things. Thank you. See you in the next.